Hi, boys and girls. Welcome to your very last math video of the year. Woo! Let's celebrate that. All right, guys, we are wrapping up chapter 11 today with our very last lesson. It is the chapter 11 review/test, but we know it's not a test that's being graded. I'm just checking for your participation in completing the 6 pages within this lesson review. So let's get it done. Grab your Go Math books and open up to page 687. We've got this, guys. Number 1 says, find the perimeter of each figure on the grid. Identify the figures that have a perimeter of 14 units. Mark all that apply. So that tells us we could have more than one answer. Remember, perimeter is the distance around. So let's start with shape A. Because these are odd shapes, we can't really just go through a quick formula of adding 2 sides and doubling it like we could do with rectangles. So we're just I'm going to trace around the shape, count the units as we go, and we're looking for the ones that measure 14 total units. So here we go. 3 across the top. 1, 2, 3 down the side, so 3 plus 3 is 6, 7, 8, 9, 10, 11, 12, 13, 14. Look at that. Our very first one works. But we shouldn't stop there, especially because the directions tell us to mark all that apply. We could have more than one answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Nope, B does not work. Let's try C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That works. So letter C has a perimeter of 14 units. And let's try D. Across the top, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Too much. So A and C end up being our correct choices. On number 2, it says that Kim wants to put trim around a picture she drew. How many centimeters of trim does Kim need for the perimeter of the picture? So we're going around the outside here, and I see that this is a square because it has 4 sides. And each side is 6 centimeters. So instead of adding 6 plus 6 plus 6 plus 6, I could do a quick multiplication. 6 times 4 or 4 times 6 equals 24. So she would need 24 centimeters of trim. Number 3, Sophia drew this rectangle on dot paper. What is the area of the rectangle? So now area is the space inside of a shape. I see that there are 2 units on the side, and it covers 4 units across the top. So we learned that we can do length times width when we have a rectangle. So 2 times 4 equals 8. And you could have gone through and counted the squares on the inside. Alrighty, cruising along to our next page. Number 4 says the drawing shows Seth's plan for a fort in his backyard. Each unit square is 1 square foot. Okay. Which equations can Seth use to find the area of the fort? Mark all that apply. So area is length times width. So let's see. He's got a length of 1, 2, 3, 4. And a width of 1, 2, 3, 4, 5, 6, 7. So to find length times width, we would do 4 times 7. You see that anywhere? Letter F. Or remember, we can always reverse those factors and do 7 times 4. You see that anywhere? 7 times 4 would be the same as letter C, 7 plus 7 plus 7 plus 7. That would mean they were adding rows of 7 to get the total of 28. Okay, so letters C and F are correct answer choices. Okay, number 5, which rectangle has a number of square units for its area equal to the number of square units of its perimeter? So we want the area and perimeter to be the same. So let's go ahead and see what we can find. Letter A, I'm going to take a look at the area. Let's see, there's 1 unit on each side, and then 1, 2, 3, 4, 5, 6, 7 across the top and bottom. So the area of shape A, length times width, would be 7 square units. And the perimeter, 7 plus 7 is 14, 1 plus 1 is 2, 14 plus 2 is 16. So those two do not have the same area and perimeter number. Let's go over to C. I'm just going side to side. It doesn't matter, A, B, C, D. I don't know. Let's just go to C. 2 units on each side and 6 units top and bottom. So area would be length times width. So 2 times 6 would equal 12. Perimeter, adding up all the sides, 6 plus 2 is 8. 6 plus 2 is 8 again. 8 plus 8 is 16. That seems a little bit closer, but again, 12 and 16 are not the same numbers, so therefore we would not say they have the same number of units for the area and perimeter. All right, so let's try B. B measures 4 across the top and bottom, and also 4 units on each side. So area would be length times width. So 4 times 4 is 16. And the perimeter would be adding up 4 times, which also equals 16. I think we found our answer. But we know we should never just stop there. We should double check our last option just to be sure. So if we have 3 units on the sides, 5 for the top and bottom, area is length times width, so 3 times 5 equals 15, and perimeter is our distance around. 5 plus 5 is 10, 3 plus 3 is 6, 10 plus 6 is 16. So close. We're going to stick with letter B. All right, moving along, number 6. Vanessa uses a roller to draw a square. The perimeter of the square is 12 centimeters. Select a number to complete the sentence. The square has a side length of how many centimeters? 3, 4, 5, or 6? Well, we know the total perimeter is 12, and we're going to divide that among the 4 sides, knowing that a square has 4 sides. And knowing that all 4 sides of a square are the same, we can evenly divide 12 by 4 to get the length of each side. So now this turns into a simple division problem. Which number completes this division equation? I hope you're thinking 3, because that is correct. All right, over to the next page. All right, so on number 7, it tells us that Thomas drew 2 rectangles on grid paper. Circle the words that make the sentence true. Rectangle A has an area that is less than, the same as, or greater than the area of rectangle B, and a perimeter that is less than, the same as, or greater than the perimeter of B. So let's find the area and perimeter of both rectangles, and then we can accurately compare them. So let's start with A. 3 units on the side, 4 on the bottom. So the area would be length times width, which equals 12. And perimeter, the distance around. 3 plus 4 is 7, plus another 7 equals 14. Okay, so let's check out B. B has 2 units on the sides and 6 units across the top and bottom. So the area Length times width. 6 times 2 would be 12. Ooh, so I see that the area is the same. So I'm going to circle the same as. Let's check out the perimeter. Perimeter would be our distance around, so I'm going to add 6 plus 6, which is 12. And the two sides are each 2, so 2 plus 2 is 4. 12 plus 4 is 16. So A's perimeter was 14. B's perimeter is 16. So we would say rectangle A has a perimeter that is less than the perimeter of rectangle B. The areas are the same, but rectangle A has a shorter perimeter. And remember, it's because rectangle A is closer to being a square than rectangle B. And we learned a couple lessons ago that when we have a shape that is more like a square, it has a shorter area because the outside doesn't have to be stretched so far. All right, let's go to number 8. Yuji drew this figure on grid paper. What is the perimeter of the figure? No problem, let's count around the outside. Here we go, 3 across the top, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 units all the way around. All right, let's go to number 9. What is the area of the figure shown? Each unit square is 1 square meter. Because this is kind of an odd shape, we can't really do like length times width to get the area, so let's just add our boxes up. I like to put little dots as I count them. So there's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we've got 13 square meters. That is the area. All right, number 10. Sean drew a rectangle that was 2 units wide and 6 units long. Draw a different rectangle that has the same perimeter but a different area. So if he drew a shape that was 2 units wide but 6 units long, first we need to figure out the perimeter and area. So the perimeter of this shape that he drew would be adding 6 plus 6, which is 12, plus 2 more, which is 14, 2 more, which makes 16. And then the area of his rectangle would be 2 times 6, which is 12. So we need to draw a rectangle that has a different perimeter. No, I'm sorry, that has the same perimeter but a different area. So instead of having an area of 12, we need to have a different area. So it could be greater or smaller. Let's see, though, for the perimeter, it has to be the same. So what if we did 4 units across the top, 4 units down the side, 4 units across the bottom, and 4 units up the other side. I chose that because I know 4 plus 4 plus 4 plus 4 equals 16, so that would get our perimeter. Let's check on the area. So for the area, I could just do length times width. That would be 4 times 4, which is also 16. So the area inside of this square would be 16, which is not the same as the area of Sean's rectangle. So that shape would certainly work. All right, number 11. Mrs. Rias put a wallpaper border around the room shown below. She used 72 feet of wallpaper border. What is the unknown side length? Show your work. So we need to figure out the length of this unknown side. Remember, if the border was 72 feet, we can figure out that missing side by adding up the sides that we do know and subtracting that from 72 to figure out the side that we don't know. So that means we're going to add together 20 plus 8 plus 14 plus 8 plus 6. Now, you can certainly break this down into a smaller addition problem. You don't have to add up all 5 numbers at once. Sometimes that can be confusing. But I'm going to work this out together with you. I see that 4 and 6 make a 10. I like that. And 8 plus 8 is a double. That makes 16. And then 16 plus 10 is 26. So I can drop my 6, regroup my 2. And now in the tens place, 2 plus 2 is 4, plus 1 more is 5. So the amount of borders she has used so far that we know is 56 feet. She used a total of 72, so we need to figure out that missing length. That means we need to subtract. And in this case, we need to do a little regrouping because when we see more on the floor, we got to go next door. So our 10s drop to a 6. That adds 10 more to our 1s, making 12. 12 minus 6 is 6. 6 minus 5 is 1. So just double checking here. What we calculated is that this missing side would equal 16 feet. Okay? Perfect. All right, guys, last problem. Number 12, Elizabeth has 2 gardens in her yard. The first garden is 6 feet long and 4 feet wide. The second garden is double the width. Oh, that's interesting. Double the width. The area of the second garden is double the area of the first garden. Now we need to go through and select true or false. You know I am a girl that loves pictures when it comes to math, so I'm going to draw a little picture here to help us visualize Elizabeth's garden. So if I drew that, and let's just say this first garden is 6 feet long and 4 feet wide, okay? And the second garden, it said, is double the width. Double the width. So if it was, and this isn't going to be drawn accurately, but when I throw my labels on, it'll help. If the width of the first garden was 4 feet and the second garden is double that, 4 doubled is 8. And it says that the area of the second garden is double the area of the first garden. Well, what would the area of the first garden be? Well, let's figure that out. 4 times 6 is 24. And if we double 24, 24 plus 24 is 48. So what must the length of the second garden be? 8 times what is 48? I don't know if my little humming helped you, but remember, 6 and 8 went on a date in 1948. So the length of her second garden would remain 6 feet long. All we did was double the width, but when we did that, it also doubled the area. Now let's go back to the questions and fill in some answers. The area of the first garden is 24 square feet. Is that true or false? It's true. We just solved that. Letter B, the area of the second garden is 48 square feet. Yeah, because 48 is doubled that of 24. The length of the second garden is 12 feet. No, we discovered the length would have to stay 6 feet in order to get an area of 48. And lastly, the length of the second garden is 6 feet. Yes, that's what we just figured out. All right, guys, that flew by in a breeze. I hope that everything that we've talked about through this virtual learning and through my videos has made sense to you. I hope you've learned a little bit. I know there might still be some areas of what we've covered that are confusing, but rest assured that in 4th grade next year, you'll be doing lots of review of this material. I taught 4th grade before, so I know that 4th grade math is very much like 3rd grade math, just a little harder and a lot more extensions on things. So you will revisit some of these skills. If you have any questions or need anything from me, please reach out. If you want to have a bonfire and burn your math book, I'm okay with that. Just get permission from mom or dad first. You could always save your Go math book though and go back through and complete some of the pages that we skipped over throughout the year or we just didn't get to. It would be a really great way to review some things over the summer. I know it's so important to keep learning. I know you'll be able to come into school at some point in June to grab the rest of your stuff there, so you'll even be able to pick up your first math book. Although I think we already sent that one home, if I remember correctly. I don't know. Anyways, guys, have a great rest of your day. Look out for some other videos for this week's learning. And as always, reach out if you need anything. Miss you guys. Bye.